Okay. Okay, we have done up to maximum error today. The maximum error, yeah. Just put it. I just may see that one. Yeah, we have done up to maximum error. Maximum error means it is equal to the least count of an instrument. Okay, and the most important thing is when you are measuring, when you are measuring, when you're taking the measurement, using the measuring instrument, actually we are going to measure the gaps, number of gaps, no? And okay. So suppose if you want to take the length reading, if you want length reading of this AB rod, you have to place this AB rod with a ruler. Then you have to take the measurement. 0, 1, 2, 3, 4, 5, 6, 7. So when you are taking a measurement, you are going to take the gap, number of gaps. 1, 2, 3, 4, 5, 6. Now there are 6 gaps. That number is mentioned here. As the scale. Therefore, this number, 1, 2, 3, 4, 5, 6. This number represent the number of gaps up to that mark. Therefore, in a scale, this is here the 0 reading. This one is 1, 2, 3, 4, 5. So this number represents the number of gaps up to this point. So there are only 1 gaps up to this point. There are 2 gaps up to this point. There are 3 gaps, 1, 2, 3 gaps up to this point. Therefore, this number represents the number of gaps up to this point. 1 gap is equal to the least count of that particular instrument. Did you get my point? Did you get this point? Everyone, I need the responses. Everyone. Okay. 1, 2, 3, 4, 5. Apa yang note pack dilakukan? This is the scale. Putih. So this value represent the number of gaps. Up to that point. Represent the number of gaps up to that point. This is a special note, Putih. This is a special note. This is the scale. This is called the gap. So the smallest gap is called as the least count. Okay. Normally we are using an equal gaps instrument with equal gaps. But sometimes there are some different kind of equipments or instrument. Those instrument doesn't have equal gaps with it. Right? Help. Okay. So when we are using the measuring instrument, as per our previous knowledge, we know there may be a error. There may be an error when we are taking measurements. When we are taking measurement using measuring instrument, there may be some errors. Therefore, the maximum error is equal to the least count of that particular instrument. And therefore, when we are taking a measurement using the measuring instrument, we have to know the least count of that particular instrument. Then we can decide whether that instrument is a suitable one or not to take that reading. Therefore, that is a mandatory thing. Okay, we have write that one. Write this in another paragraph. Make a punji note. First, you have to note down this note, this special note. Have you finished this one? Have you finished? Okay. Then write this under that. Write this separately. Make a note separately. Before using any measuring instrument, it is essential to know about its least count.
Sir, to know about its
least count. Know about its least count. It is essential to know about its least count to get an understanding about the maximum error. To get an understanding about the maximum error of the instrument. Okay. Now tell me, you are going to use this measuring instrument. And now you are going to use this measuring instrument to measure the distance, measure the length of this rod. Now you are going to use this measuring instrument to take the length of this rod. Now this rod is here. Now it is very clear. It is very clear. Up to this point, you can get a direct value. But from here to here, suppose this one is C. From C to B, you cannot get a direct value. You have to assume. You have to assume a value. That assumed value can be within 2 to 3. Can be within 2 to 3. Therefore, there will be a maximum error within that range. Okay? So that is equal to the least count of this scale. Okay. Anyway, if the reading cannot be measured directly, using a measuring instrument, it is obvious there is a error associated with this reading. Did you get my point? තේරුණාද? ඒ කියන්නේ පුතේ measuring instrument එකෙන් අපිට directly measure කරන්න බැරි නම් මොකක් හරි reading එකක් අනිවාර්යෙන් ඒ reading එකේ error එකක් associate වෙලා තියෙනවා. Did you get my point? Everyone. Quick response. I need quick response. Thank you. Oh. Kattiya. So then now there's a question. Now there's error. Now if definitely there might be error. Correct. So to reduce that error, what kind of thing can be done? Can you give me a proposal? What kind of
So
thing?
we could add small units.
Sorry, what?
Adding small units in between the two numbers.
Okay. Another proposal? Yes, Putin. Very good. Very good proposal it is. Okay. Suppose now I am going to take this measurement, take the same measurement using this kind of scale. Look at this. This kind of scale. Then what is it? Now look at you can see. Look at this. Now we have that behind. Look at this one. Initially, the error might be this much of distance. The error might be this much of distance. But if I reduce the least count, then what will happen? Look at this one. There's very small distance to be assumed. Or sometimes that distance can be neglected. But in previous case, there's a very large distance to be assumed. But after reducing the least count. After reducing the least count, then what will happen? This distance to be assumed decreases. And on the other hand, due to the reduction of this least count, the maximum error that can be occurred reduces. Because maximum error is equal to least count. The maximum error is equal to least count. Now least count is reduced. Therefore, the maximum error that can be occurred reduces. Okay. Therefore, by reducing the least count, we can take very sensitive reading. Okay. That means the accuracy of the instrument increases by reducing the least count. Did you get my point? Very late. Okay. Then you have to draw this one. This is scale number 1. This is scale number 2. ඒක පැහැදිලිව පේන්නේ නැද්ද ගන්න? Okay. Write this under the figure. Write this under the figure, Pute. If we are going to take a reading, that cannot be measured that cannot be measured directly by a measuring instrument, that cannot be measured directly by a measuring instrument, there will be an error, there will be an error, there will be an error, there will be an error associated with that reading, associated with that reading.
Sir, associated with that?
Reading, the reading. Okay, write in another write in another paragraph, new one. But comma, if the least count is reduced, if the least count is reduced, as in the figure 2, as in the figure 2, then we can take, take the reading, without a significant error, without a significant error. Okay, with it. Then write another para. There are special measuring instruments. There are special measuring instruments which are being used, which are being used, which are being used, which are being used, which are being used in such instances, in such instances, And there are two main principles. There are two main principles. There are two main principles. Use in these instruments. Use in these instruments. Use in these instruments. There are two main principles used in these instruments. The first principle is the vernier principle. The second one is the screw principle. Very good. Now we can build a logic. Now we can build a logic with it. Now it is very clear when you are taking a measurement or when you are taking a reading, if the reading is not fit with the instrument scale, then definitely there will be a error. And to reduce that error, we have to reduce the least count. That is very clear. We have reduced least count. Okay. So that means if you want to increase the accuracy, we have to reduce the least count as much as possible. So if you reduce the least count in this scale, then there will be a practical issue. What is that one? What is that? If you reduce the scale, if you reduce the least count in this scale, there will be a practical issue. Yes, very good. Very good. We cannot treat this one, no? We can reduce the least count, but using our naked eye, we cannot take the measurements. Sometimes we can see all the overlaps. Okay? Therefore, as a theoretical argument, reducing the least count is a very good thing. But in practical way, it is not a practical thing because we cannot see the scale. So to overcome this issue, we will use two scales. So according to vernier principle is created by a scientist. His name is vernier. That is why this principle is called the vernier principle. But according to Vernier's principle, he used two scales instead of one scale because the problem was this one. If we reduce the scale, if we reduce the least count, it is very good for accuracy. But the thing is, it is not a readable one. So Vernier made another scale. That means he used two scales instead of one scale to minimize or to mitigate this problem. high. That means he used this kind of instrument. Suppose now this is our main scale. Now this is our main scale. Suppose this is our main scale. There are five marks, okay? 3, 4. So this is the main scale. මොකක්ද දන්නවද vernier කරේ? Actually vernier when you use this vernier is main scale and he created another scale by dividing a certain length of a main scale into another number of divisions. And මොකද්ද vernier කළේ? Vernier කළේ he chose a certain length of the main scale and he divided that main scale into another number of division, which is more than the number of division of main scale. It is not a mandatory thing. Again, more than or less than it is not a mandatory thing, but as a usual practice, he selected a certain length, and he divided the certain length into another number of divisions. And as an example, we can divide this length. Now there are 5 divisions. Now we can create, or now we can make another scale by dividing this length into 6. Look at this one. Now I am creating another scale by dividing this scale into 6. Zero, 1, 2, 3, 4, 5, 6. So this is the main scale. So along with the main scale, he used another scale. That is called the vernier scale. Vernier scale is made by dividing a certain length of the main scale into another number of divisions. And did you get my point? තේරුණාද? මොකද්ද කරේ කිව්වේ? අයි මේක කරේ කියලා මම කියා දෙන්න. Did you get my point? So now this scientist had 2 scales. Now we have two scales, Puta. Now we have two scales in one measuring instrument. That's the most important case. Now we have two scale in one measuring instrument. And so what is the reason for that? My concern is reducing the least count. My concern is reducing the least count. But I cannot reduce the least count because sometimes it may not be visible. Okay. Therefore, to avoid or to mitigate that problem, now we have used another very creative method. What is that method? We are going to use another scale along with the main scale, and that scale is made by dividing a certain length of a main scale into another number of divisions. And then අපි බලමු කොහොමද මේකෙන් least count එක අඩු වෙන්නේ. Now tell me, what is the least count of an instrument? What is the least count of the instrument? Now tell me, what is the least count of the instrument? Huh? Yes. 0.1. No, Pute. The smallest gap. We have done that one. It is the smallest gap in between two consecutive marks. No, it is the smallest gap. Okay. Don't memorize other things. It is equal to the smallest gap. Now tell me, what is the least count of this instrument? What is the least count of this instrument?
6.
6. But what is the least count of this instrument? Least count is the smallest gap that can be measured using the instrument. It's the smallest gap that can be measured using the instrument. Now tell me, what would be the smallest gap of this instrument?
Sir, the Venus scale represents the least count number.
Look at this something. But you can measure this gap, no? You can measure this value. So you can measure this value, no? Okay. Suppose this gap is X. You can measure this value, no? You can measure this value. This gap can be measured, no? X can be measured, no? Is that okay? You can measure this gap, no? Then, or lies. You can measure this gap. Is that okay? Then you can measure this gap, no? Is that the smallest? Is that the smallest gap? No, it is not the smallest gap. It is not the smallest gap. But you can measure this gap. You can measure this gap. Another thing, you can measure this gap also, no? You can measure this gap. Yeah. You can measure this gap. And do you agree with me? Do you agree with me? Can you measure this gap and can you measure this gap? Please listen to me very carefully. If you can measure this gap and if you can measure that gap, then you can determine the gap between these two marks. What is the gap between these two marks? It is equal to x minus 1. X minus 1. Look at that one. Suppose this gap is D. Suppose this gap is D. Suppose this gap is D. So you can measure the gap between these two marks. So D is equal x minus y puta, x minus y. So you can determine this gap. You can determine this gap. Okay. Actually, you cannot determine this gap directly, but you can measure that gap. That means you can determine this gap. So this gap is the smallest gap of this instrument that can be measured. Did you get my point? Huh? Main gap measure the smallest gap. Did you get my point? Did you get my point? So if this gap is D, if this gap is D, D means gap between first and number one scale of the main scale and number one scale of the main one scale. And so if this gap is D, then definitely this gap is equal to D, no? This gap should be equal to D. Right? Therefore, both gaps should be added. Therefore, if this gap is 2D, this gap should be, so if this gap is D, this gap should be 2D. Did you get my point? The gap between these two scale, these two mark is D. If this one is D, gap between these two marks should be 2D because there's 1D here, another D should be here, therefore both should be added. Then, what is the gap between these two? What is the gap between these two? It should be 3 times D. It should be 3 times D. It should be 3 times D. This one should be 4 times D. This one should be 5 times D. 5 times D. Did you get my point? Did you get my point? This one should be 5 times D. And this one is D, 2D, 3D, 4D, and 5D. And look at this one. The gap between two consecutive marks, the gap between two consecutive marks of the vernier scale is equal 5 times D. 5 times D. X minus 1. X is the length, the gap between, or this count, or gap between two consecutive marks of the main scale. Y means the gap between two consecutive marks of the vernier scale. Yes, yes. Unless only this gap should be this gap should be D. This gap should be D. And your concern is okay. Your concern is okay, but the least count means it is the smallest gap that can be measured. It is the smallest gap that can be measured. Therefore, the smallest gap that can be measured is called D. Whether you measure in between these two or in between these two, it is equal to D. You got my point? Huh? Therefore, least count is D. The least count is D. This what may vary. Huh? Therefore, least count of this scale is equal to d to the. That is the smallest gap that can be measured. That can be measured. මම මේක කොහොමද මේ measure කරන්න පුළුවන් වෙන්නේ කියන දේ ඔයාලට පොඩි ප්‍රශ්නයක් වෙයි. Now there is a problem. What is the meaning of that can be measured? I will explain that thing when we are doing how to take a reading using a vernier scale, and when we are doing the way of taking measurement using a vernier scale, then I will discuss how to take the reading. Okay, so until then you can understand this thing. This is the smallest gap. This is the smallest gap that can be measured. And therefore, the smallest gap in main scale, in the main scale is equal to S. The smallest gap in the vernier scale is equal to what? By combining these two scales, we can reduce the smallest gap that can be measured using this entire instrument up to x minus y. That is very, very smallest value put it, because it is very much less than x as well as y. Okay, now we can calculate the least count. This is the least count of the instrument. This is the least count of the instrument. Okay. Apa yang menjaga? Ini gimana The next topic is vernier principle. The vernier principle. The next topic is the vernier principle. Okay. Once you write the topic, then draw this figure. Figure again. Once you complete, please let me know. Okay. They write this one. The least count of an instrument, the least count of an instrument cannot be reduced as our wish, cannot be reduced as our wish, because the scale might not be visible to take readings. To overcome this issue, the vernier principle was developed. The vernier principle was developed. Write it in the para. The least count of an instrument. The least count of an instrument is the smallest gap. The smallest gap that can be measured using the instrument. Using the instrument. That can be measured using the instrument. This can be achieved. This can be achieved this can be achieved by using two scales. By using two scales. Instead of one scale. Instead of one scale. Right, another para. In the Vernier principle, in the Vernier principle, comma, in the Vernier principle, a specific number of divisions in the main scale, I will repeat it again. In the Vernier principle, a specific number of divisions, in the main scale, are divided into a different number of divisions. To construct the Vernier scale. Okay. Okay. Then write the next topic. The least count the least count of a measuring instrument, the least count of a measuring instrument with a vernier principle, the least count of a measuring instrument, with the vernier principle. Okay, you have to know this one again. Make a Okay, with you. Okay. Okay. You can have 5 minutes. You can have 5 minutes. No. No, one student's request may a 5 minutes break for prayers. He can have. I that may what the billion on a billion. Have 5 minutes, okay? I pray with the material request with the request of the same back in the back. We have to overland up with that what the billion on a billion. Break cake, maybe. Break cake, not a break cake. Shall we start? Okay. Okay, I will explain until they come. Okay, I will explain until they come. But okay, what is a least count? Okay, what is a least count? As argument, what is the least count? So it is the minimum. It is a minimum reading that can be taken using a instrument. Using an instrument, it is a minimum reading. It is a minimum reading. So according to that logic, it is a minimum reading. Minimum reading is equal to the minimum gap. It is equal to minimum gap. And so it is a minimum reading that can be taken using this measuring instrument. You know this length. It is equal to x. You know this length. It is also equal to y. It is also equal to y. Therefore, the minimum reading that can be taken using this instrument is equal to x minus 1. X minus, because x can be taken, y can be taken, then x minus y can be written. Therefore, the minimum reading is the minimum gap. The minimum gap that can be taken, or that can be taken using the measuring instrument. I will impact. Okay. Okay. Let's go to the unit. So according to our argument, the least count is the minimum reading. It is the minimum reading that can be taken using the measuring instrument. So minimum reading is equal to the minimum, or there is the smallest gap. It is the smallest gap in this measuring instrument. So by looking at this measuring instrument, so what is the smallest gap? The smallest gap is the gap between the initial gap between the main scale reading and the vernier scale reading. So this is the gap between the main scale reading and the vernier scale reading. So it is the initial gap. And so that is the smallest gap in this measuring instrument. Therefore, that gap is the smallest gap that can be measured using this measuring instrument. Therefore, that is the least count of the measuring instrument. And did you get my point? තේරුණාද මේ point එක? මේක හරියටම තේරුම් ගන්න ඕන point එක. තේරුණාද මේ point එක? මොකද්ද මේ least count එක කියන්නේ? මට හැමෝගෙම respond ඕනේ. I need responses from everyone. Thank you. Others? Write this one, Pute. Write this one under top, under the topic. Under this figure. Memory, the least count is the minimum reading. Is the minimum reading is the minimum reading that can be taken using the instrument. As we discussed earlier, we measure gaps in the scale, as the reading. Look at this one. Suppose there's a scale like this. So if you want to measure the distance of the stone, how to measure the distance, how to measure the length of the stone? You have to take the number of gaps. You have to take the number of gaps from A to B. Therefore, the length of AB is equal to 3 millimeter. 3 millimeter. If this gap is equal to 1 millimeter, then it is equal to 3 millimeter. So, when we are taking a measurement, when we are taking a reading, normally we are going to take the gaps. And as I mentioned earlier, this number represents the number of gaps up to this point. The number represents the number of gaps up to this point from the beginning. So, a reading means it is equal to a number of gaps between. Number of gaps. First point, Pute, first point means you means that
The point before this point, sir. The point you said before this last point.
you means about our paragraph, not?
Yeah, sir. The paragraph before paragraph.
So what is the last sentence you wrote?
As we discussed earlier, we measure gap in the scale as the reading.
as we discussed earlier, as we discussed earlier, we measure gaps. We measure gaps. We measure gaps in the scale. We measure gaps in the scale.
No, sir.
As
I want to know the point before that point.
before that point.
Yeah.
Oh. Can anyone repeat the sentence before that point? Actually, I don't remember that one. The least count is the minimum reading that can be taken using the instrument. Thank you, Bute. Thank you very much. Okay. Everyone, please look at the board. කට්ටිය බලගන්න board එක. හරි පුතේ. ඒ කියන්නේ බලන්න. Okay, look at the board. That means when you are taking a measurement, that means you are going to take the number of gaps. Therefore, the least count means it should be the smallest gap, no? Yeah. Because according to our investigation, it is obvious. A reading means it is equal to the number of gaps. Between the initial point and the final point. So if it is equal to a number of gaps, that means we are going to measure the gaps. The least count should be the smallest gap, no? It is the smallest value that can be taken using that instrument. And okay. Therefore, the least count should be the smallest gap. That can be measured. Using a measuring instrument. අපිට ලියන්න පුළුවන් පුතේ මේක ලියලා කොටු කරගන්න the least count of a vernier instrument is equal to the smallest gap between two marks. It is the smallest gap between two marks. හරිද? Okay, write down on that. Write down on that. Therefore, the least count, the least count of the instrument mentioned above, of the instrument mentioned above, mentioned above, should be equal to the, should be equal to the, should be equal to simple D. Should be equal to simple D. මෙහෙම නිකන් වචනෙන් වල තේරෙන්නේ නැහැ නේ පුතේ. ඒකයි මම අර simple D දෙන්නේ. Therefore, the least count is equal to simple D පුතේ. That is equal to x minus y. Simple D is equal to x minus y. Okay. Therefore, the least count. Okay, write that one. Simple D. The least count. Simple D is equal to x minus y. X here again, what with it? X means it is the value. It is the value of a division. It is a value of a division in the main scale. Y means it is the value of a division in the vernier scale. The vernier scale. Therefore, the least count is equal to the value of a division in the main scale, that is x to the, that is x minus the value of a division in the vernier scale. That is what. මේකත් කොටු කරගන්න. Right. Now we can calculate this. Now we can calculate this. Done. Make up calculation. Okay. Look at this one. You know the value of x. Value of x is suppose this one is millimeter scale. It is equal to 1 millimeter. This is equal to 1 millimeter. Now, because the main scale is in 1 millimeter. So if the main scale is in 1 millimeter, x is equal to 1 millimeter. Because I know the main scale is in 1 millimeter scale. Suppose it is a some ruler. So if it is a ruler, we know the main scale is in millimeters. So if the main scale is in millimeters, therefore this gap should be equal to 1 millimeter. Is that clear? Is that clear? If the main scale is in millimeter scale, this gap should be equal to 1 millimeter. Is that clear? Miriam? Or Terile? Look at this one. Now you know 5 divisions in the main scale is divided into 6 divisions in the main scale. 5 divisions means 5 millimeter. No? 5 divisions means 5 millimeter. 5 millimeter is divided into 6 equal divisions in the main scale. Now tell me then what is the value of pi? What is the value of pi? Then tell me what is the value of pi?
5 divided by 6.
5 divided by 6. Very good. 5 divided by 6. Therefore, what is the value of pi? What is the value of pi? Y is equal to 5 divided by 6 because 5 millimeter is divided into 6 equal parts. Therefore 5 millimeter in the main scale is divided into 6 equal parts, equal divisions. The vernier scale. The vernier scale. Therefore, y is equal to 5 millimeter over 6. So d is equal to x minus 5 with it. That means 1 minus 5 over 6. That is equal to 1 over 6 millimeters. Therefore, the least count is equal to 1 over 6. Initially, the least count is equal to 1 millimeter. Now, if I combine with the vernier scale, the least count is equal to 1 over 6. That means 6 times correct accuracy. Okay. There are this one. X is equal to 1 millimeter. Therefore, 5 millimeter in the main scale is divided into 6 equal divisions in the vernier scale. So, therefore, y is equal to 5 millimeter. D is equal to x minus 1. Therefore, D is equal to 1 over 6 millimeter. No. do not need to draw the diagram. මම මේක දැක්කේ නැත්නම් මට මේක එක්ස්ප්ලেইন කරන්න ඕනේ කියලා හිතුවා. දැන් නම් ඕනේ. දැන් මම කරන්න ඕනේ. Once you finish writing, please let me know. Once you complete writing, please let me know. Okay. Hello. Suppose now now there is a main scale. Suppose this main scale has capital N divisions. Suppose this main scale has capital N divisions. Capital N divisions. The mama common formula එකක් මේ derive කරන්න හදන්න පුතේ. හරිද? Right. Look at the board again. Suppose now there are capital N divisions in the main scale. Main scale. Now this main scale, the capital N number of divisions, are divided into simple N number of divisions. Simple N number of divisions in the vernier scale. So those are divided into simple N numbers. Simple N number of divisions in vernier scale. This is vernier scale. Okay, look at this. As this is the main scale, we use capital N. As this is the vernier scale, we use normally simple N. Okay. ඒක මේ thumb rule එකක් නේ මේක එහෙම අර මොකද්ද කෙලින්ම අර standard rule එකක් නෙවෙයි නමුත් අර as a thumb rule we use capital N for main scale simple n for Vernier scale. And therefore, capital N number of divisions are divided into simple n number of divisions in main scale. Okay. Suppose this length is x, this length is y. So, according to our previous explanation, the least count should be equal to x minus 1. The least count should be equal to x minus 1. Is that clear? Is that clear? All right. Look at this one. As there are n divisions, that means there should be capital N number of gaps. Capital N number of gaps in the main scale. Capital N number of gaps in the main scale. So that is equal to simple n number of gaps. Simple n number of gaps in the Vernier scale. Did you get my that point? Main scale එකේ තියෙන කොහොමද පුතේ? Main scale එකේ තියෙන gaps ටිකක් තියෙනවා. Main scale එකේ gaps capital N number of ගණනක් තියෙනවා. In the Vernier scale, there are only simple n number of gaps. Did you get my point? තේරුණාද? Okay. N divisions means pute that is equal to n, capital N number of gaps. This is equal to simple n number of gaps. Okay. N gaps simple. So that means from here to here, there are capital N number of gaps. Capital N number of gaps. That means from A to B. From A to B length. AB length can be right. Therefore, AB length is equal 1 gap into n times. Make x net in. The distance between one gap is x. The distance between one gap is x. How many gaps are there? N gaps. How many gaps are there? N gaps. Therefore, AB length is equal nx. Did you get that point? Right there, no? How do we get next out here? length. Explain the gap between main scale main scale calculation the gap the distance of a gap is equal to x number of gaps is equal to capital N. Distance of a one gap is x, put it, the number of gaps is capital N. Therefore, AB length is equal to nx, capital Nx. AB length is equal to capital Nx. AB length is equal to capital Nx. No, we cannot take simple nx. Simple n is, it is equal to, look at this, y times n. It is equal to y times n today, not nx, simple nx. X is equal to one. X is equal to the gap between 1 by 2 consecutive marks in the main scale. But X is equal to 2 consecutive marks in the main scale. How many marks are there? How many gaps are there? There are n capital N gaps. N gaps. Therefore, distance from here to here is equal to capital N simple x. Capital N simple x. Yes. So this is for main scale. Now we can do this for vernier scale. Vernier scale. Vernier scale. Look at this one. The distance between one gap. The distance between the distance of a gap. The distance of a gap. The distance of a gap is equal to y. The distance of a gap is equal to y. Now there are simple n number of gaps. Y, 2y, 3y, 4y. Now there are simple n number of gaps. That means from A to B, there are how many number of gaps? Simple n. The number of gaps is equal to simple a. Therefore, AB length can be written as, therefore, AB length is equal to simple ny. Simple ny. The distance between one gap is x. There are capital N number of gaps. Therefore, here to here, the length is capital N times x. The distance between one gap is y. Now there are simple n number of gaps from here to here. So the distance is equal to simple n times y. Everyone, I need your responses. But I have more game responses only. Shaminder, Deodu. Okay. Okay. Shaminder, do you have a question? Okay. Okay. That means AB length can be written as capital N times X or simple N times Y. Simple N times Y. Therefore, capital N times X is equal to simple N times Y. Therefore, I can write this one. Therefore, capital Nx is equal to simple Ny. Therefore, y is equal to Nx over simple A. Nx over simple A. Nx over simple A. Therefore, D is equal to x minus y. Therefore, that is equal to x minus Nx over A. Nx over A. So if you take x here, therefore D is equal to x times simple N minus capital A over A. This is very, very important relationship. This is very, very important relationship. One. Simple N minus capital N. Simple N minus capital N is, that is the difference between the divisions in main scale and division is vernier scale. Division in vernier scale and main scale. That is the difference. And it is divided by the number of division in the vernier scale. Vernier scale. So number of divisions is a vernier scale, and it is multiplied with the length of or smallest gap, or gap between two consecutive marks in the main scale. X means it is the value of a division. It is a value of a division in the main scale. Are you clear? Terium, Shaminda, Lulu, perhaps did it. What about others? I make explain කරන්න ඕන දාපු හැටි නැත්නම් ආයි මේක කොහොමද clear the I will explain it again බලන්න හැමෝම you mean actually now I am going to calculate the least count is d is equal x minus y. Now I have to find those values. So I have assumed actually that this is the assumed scale quantity. So according to this given figure, capital N number of divisions in the main scale is divided into simple N number of division in the vernier scale. Yes. This is for finding least count to find least count. Okay, look at this one. So this one, the value of a gap in the main scale is x. The value of a gap in the vernier scale is equal to y, and therefore the least count is equal to d is equal to x minus y. And now you know the gap between two consecutive marks. The gap between two consecutive marks in the main scale is equal to x. There are capital number of gaps here. Capital N number of gaps here. Therefore, from here to here, the distance should be equal to capital N x. Likewise, the distance from here to here should be equal to n, simple n times y. Because y is equal to the distance between one gap. There are simple n number of gaps from here to here. Therefore, AB is equal to simple n into y as well as capital N into x. That's why I equate this way. From that one, I can subject y and find y. Then d is equal to x minus y. So x minus y means nx over y. So if I take x as a common factor, then that is equal to simple n minus capital N over y. මේක නිසා මේක ලොකුවට තේරුම් ගන්න ඕන equation එක මාරම lazy equation එක මේක n minus n means ඒක කියන්නේ පුතේ මේ කියන්නේ මොකද divisions අතර වෙනස vernier division එකයි main scale එකේ division එක අතර තියෙන difference එක වෙනස මේ තියෙන්නේ vernier divisions ගන්න x කියලා කියන්නේ main scale එකේ division එක value එක so this is the difference between two divisions. This is the difference between the division in the main scale and the vernier scale. Simple n means the number of division in the vernier scale. Capital X means there is a value of a division in the main scale. Okay. Tagala mega prokaragana. Yeah, you have to draw this diagram. You have to draw this diagram. Then you have to prove up to this. Sorry, just draw the diagram. Just draw the diagram. Then I will give a special sentence. Then go beyond that. First draw the diagram. First draw the diagram. Then I will give a sentence. Diagram එකෙන් මට කියන්න. Okay, Buti. Find this one. Find this one under the figure. Suppose capital N number of divisions. Capital N number of divisions in the main scale suppose capital N number of divisions in the main scale is divided. Sorry, are divided. Capital N number of divisions in the main scales are divided into simple n number of divisions in the vernier scale. Simple n number of divisions in the vernier scale. Okay. It's about the question here. Actually, you want to calculate the gap. You want to calculate the gap with it. This is not a mathematical thing. This is not a mathematical thing. If you want to calculate a gap, then how do you calculate the gap? You have to subtract from the larger one, where you have to subtract the larger one from the smaller one. No? You cannot reverse that one. And this is not an arithmetic thing. And please consider the argument. Please consider the argument. Now we are going to take the gap. Because this gap is the smallest gap that can be measured. And so to find the gap, what should you do? You cannot subtract the vernier one by this main scale one. You have to subtract the larger one from the smaller one. And gap එකක් මනින්න කොහොමද? Gap එකක් මනින්නේ large එකෙන් small එකට කරන්නේ. Gap එකක් කියනකොට හැම වෙලෙම ඉතින් ඒක scale quantity එකක් නෙමෙයි. ඒකට positive negative තියනවද? Negative gap කියලා තියනවද නෑනේ. There's no meaning of negative gaps. Okay. Therefore, no need to subtract y minus x. No need to do that. And because now I am going to determine the gap. Okay? Did you get my point? Did you get my point, Putin? You want to calculate the gap puthe. You want to calculate the gap. Gap is a positive value puthe. It is not a negative value. Gap it is just a value. Now you can write this one from here to here. Sharad. Shall I rest? Hi. Now this equation, now this is the equation is equal x times n minus capital N over n. This is the equation. Here equation x is x in. It is the value of the gap in main scale. The main scale. Gap of. This is the difference. Difference of number divisions in main scale and main scale. Difference of number of divisions in main scale and the main scale. So this one, n is the number of divisions in the vernier scale. Hello. Okay. Now tell me, do you have any question regarding this explanation? Do you have any question? Have any? පුතේ මේ equation එක මම use කරන equation එක දැන් ඊට පස්සේ මම ඕගොල්ලන්ට ඊට පස්සේ කියා දෙනවා අර ඕගොල්ලෝ කටපාඩම් කරන වගේ equations තියෙනවා කියලා. හරිද? මේ ඒක එතනද මම කියා දෙනවා කොහොමද මේක වෙන්නේ කියලා. හරිද? හරි. Before that, tell me, do you have any questions regarding this one? Do you have any questions regarding this one? Are you clear? Are you clear? Please, once you before you come to the next class, please go through the note and please derive this equation with your අනිවාර්යෙන් ගිහිල්ලා තනියම මේ formula එක ඔයාලා prove කරන්න with yourself. Okay. Then now this is the main formula. Okay, this is the main formula that can be used to any cases. This formula can be used to any cases, but we can derive some different formulas for some special cases. Okay, so using this formula, we can derive another derived formula for some special cases. Now we are going to look into that cases with it. Then they write the topic. They write topic and a special topic. Some special cases of this formula. Some special cases of this formula. Some special cases of this formula. Number one. What's this? If x equal 1, then what will happen? If x equal 1, look at this one. If x equal 1, then what will happen? X equal 1, what is the meaning of that one? What is the meaning of that one? If x equal 1, what is the meaning of that one? That means, sorry then?
The value of the gap is 1.
Yes. The main scale, the value of the gap in the main scale is equal to 1. That means main scale may be a millimeter scale. As we mentioned earlier, it might be a millimeter scale, or it may be any other scale, something may degree or some kind of thing. But the main scale should be scale 1 by 1. That means 1 millimeter, 2 millimeter, 3 millimeter, likewise. Okay. Therefore, the gap between two consecutive marks in the main scale should be equal to 1. That 1 may be a millimeter, maybe a degree, maybe any other scale, maybe Celsius, any other scale. But you have to understand that the gap between two consecutive marks in the main scale should be equal to 1. If so, x is equal to 1, then d is equal to here 1 n minus capital N over simple A. Then you can divide these two terms separately. If you divide these two terms separately, n over n minus capital N over simple A. N over n, it is equal to 1. Therefore, d is equal to 1 minus capital N over simple n. D is equal to 1 minus capital N over simple n. You may see this equation. Sometimes you have some experience with this equation. But you have to understand this thing. You should use this equation where the value of x is equal to 1. Otherwise, you cannot use this equation. නැත්තම් මේක තමයි ගොඩක් ළමයි කටපාඩම් කරන equation එක. මේක කටපාඩම් කරගත්තා හැම තැනම apply කරනවා. හරිද? ඔක තමයි වෙන්නේ. හැබැයි මතක තියාගන්න මේක මේ prove කරන්න පුතේ x equal එකට. ඕක කියලා දෙන්නෙත් නැහැ. ඔක සමානට මේක ඇහෙන්නෙත් නැහැ. මේක මතක තියාගන්නවා. ඩෝංගා දාන හැමතැනම. හැබැයි තේරුම් ගන්න ඕනේ මෙන්න මේකයි original එක. This is the original equation. From this equation I can derive this one. Okay, so this is valid for only x if the value of x is equal to 1. Okay, that pass me this one. This one. If x is equal to 1 means the main scale is divided into this kind of thing. 1, 0, 1, 2, 3, 4, something like this. Can you take a ruler? If you take a ruler, it is divided into millimeter scale. Millimeter scale means the gap between two consecutive marks is equal to what? X is equal to what? X is equal to 1. So this may be millimeter, this may be degree, this may be any kind of scale. But the thing is, the gap between these two scale, the gap between these two consecutive marks should be equal to 1. X should be equal to 1. If x is equal to 1, then I can assign x. I can assign that value into this equation. If I assign this value into this equation, then d is equal to x is equal to 1 n minus n over n. Then I can divide each terms separately. Then I can divide each term separately by simple n. If I divide each term separately by simple n, then you will have this formula. Then n to n will be cancelled out. That is 1. That is therefore d is equal to 1 minus capital N over simple n. Did you get my point? Everyone, I need your responses. Everyone, I need your responses. So you can use this equation where the value of x is equal to 1. Okay. Otherwise, you cannot use it. හැමතැනම කෝරත් තයිල වගේ use කරන්න එපා. කෝරත් තයිල වගේ use කරන්න පුළුවන් එකම equation එක උදේ මේ. හරිද? Are you clear with me? තේරුණාද? If you have any questions, please let me know. If you have any questions, please let me know regarding this one.
Should I copy this? No.
Sorry, Pute?
Should I copy this? No.
Wait. You have write up this one, no? You have write up this one. Then, the first case, if x is equal to 1, write this one only. If x is equal to 1, if x is equal to 1, they write on that. That means the value of main scale division, is equal to 1. Is equal to 1. You can write this one. You can draw this one. Once you draw this one, then write this. Therefore, this is equal to this one. So this is equal to this equation. 1 minus. Okay, write this under. Write this another equation. We can use this equation. We can use this equation. We can use this equation. When the x value is equal to 1, when the x value is equal to 1. Okay, do this question today. Make question ekram. Okay. Do this question. A vernier caliper, sorry, caliper. A vernier scale. A vernier scale. A vernier scale. Is constructed A Vernier scale is constructed by dividing 9 divisions in the main scale, 9 divisions in the main scale. Nine divisions in the main scale, which is calibrated in millimeters, into 10 equal divisions in the Vernier scale, into 10 equal divisions in the Vernier scale. Find the least count. Find the least count. Find the least count. Okay. When you are finding the least count, please use both the equations. One is this one, and the one is 1 minus n over n. Actually, this can be used when the x value is equal to x, where x value is equal to 1 put, okay? Otherwise, we cannot use this equation. Which is calibrated into, sorry, which is calibrated in millimeters, which is calibrated in millimeters, into 10 equal divisions in the Vernier scale. The Vernier scale. Okay. Therefore, capital N is equal to 9, simple N is equal to 10. There are 9 divisions in the main scale. That 9 divisions are divided into 10 divisions in the Vernier scale. Therefore, simple capital N is 9, simple N is 10. Simple N is 10. As this is calibrated in millimeter scales, therefore x value should be equal to 1 millimeter. Therefore, D is equal to 1 into n minus n is 1 over 10. That means it is equal to 1 over 10 millimeters. D is equal to 1 over 10 millimeters. So if we use this equation, so D is equal 1 minus capital N is equal to 9, simple N is equal to 10, 1 minus 9 over 10, therefore 10 minus 9 over 8, that is 1 over 10. 1 over 10 millimeters. 1 over 10 millimeters. Not Okay. So that's the first application today. Now we can write the second one. If second application, special case, if simple n is equal capital N plus 1. If simple n is equal capital N plus 1. If simple n is equal capital N plus 1. That means capital N number of divisions. Capital N number of divisions. Capital N number of divisions in the main scale. Capital N number of division in the main scale is divided into N plus 1 number of divisions in the vernier scale. Therefore, vernier scale has N plus 1 number of divisions. N plus 1 number of divisions. As in the previous example, there are 9 divisions in the main scale, and that are divided into 10 divisions in the main scale. 9 divisions in the main scale divided into 10 divisions in the vernier scale. And 9 divisions to the 10 division. 9 division into the 10 division. 9 division into 10 divisions. Okay. And therefore, the second case is if simple n is equal to capital N plus 1. That means simple capital N times capital N number of divisions in the main scale are divided into N plus 1 number of divisions in the main scale. In the vernier scale. Main scale into vernier scale. Okay, draw this one. Draw this one. Okay. So in this case, capital N number of divisions in the main scale are divided capital N plus 1 number of divisions in the vernier scale. ඒ කියන්නේ බර්නි ස්කේල් එකේ ඩිවිෂන්ස් ගන්නයි මේන් ස්කේල් එකේ ඩිවිෂන්ස් ගන්න ඇතුළත තියෙන ગેප් එක පුතේ එකයි කියන්නේ. Look at this example. 9 divisions in the main scale are divided into 10 number of divisions in the Bernese scale. And therefore, difference between two scales, the difference between the number of divisions, difference between the number of divisions in two scales is equal to 1. Example like that. Okay. If so, what will happen? So this is equal to x times simple n minus capital N over simple n. Now n is equal to n plus 1. N is equal to n plus 1. Now n is equal to capital N plus 1. Therefore, d is equal to x. N means n plus 1 minus n over n plus 1. Therefore, n to n will be cancelled out. So d is equal. So in such cases, d is equal x over n plus 1. X over n plus 1. X over n plus 1. Where did I have it now? Try this one. Okay, once you complete writing, please do the previous example using this method. Please do the previous example using this method. So in the previous example, there was a main body scale. Actually, the main scale has 9 divisions, and that 9 divisions are divided into 10 equal divisions in the Bernese scale. Okay. Therefore, number of divisions, the difference between number of divisions is equal to 1. Not any. n plus 1 කියලා කියනත් පුළුවන් නැත්නම් අපි simple n කියලා දාන්නත් පුළුවන්. හරි. මේක equal එකක් දාගන්න. This is equal x over simple n. X over simple n. මේකත් හොඳ ලස්සනයි. තේරෙනවද? හරි simple n is equal to capital N plus 1. That is equal to simple. This is simple n. Okay, look at this one. In previous case, x is equal to 1. X is equal to 1 because it is in millimeter scale, and 9 divisions in the main scale. 9 divisions in the main scale is equal to 10 divisions in the vernier scale. Therefore, the number of divisions in the vernier scale is equal to 10. Therefore, simple N is equal to 10. X is equal to 1. X is equal to 1. N is equal to 10. Therefore, answer is 1 over 10. The answer is 1 over 10. And X is equal to 1. N is equal to 10 to 10. And what is that? D is equal to 1 over 10. 1 over 10 millimeters. හරිද? Okay. Try this question, Puti. Try this question. Make question එක දාගන්න. Do you have any questions regarding these equations? Actually, you don't want to remember all the equations. If you can remember the first equation, then you can simply memorize the other two. And the only thing you have to remember the first equation. That is the main one. And try this question, Puti. Taggal me question again. Example number 1. In a certain measuring instrument, the main scale consists of the main scale consists of 0.5 millimeter divisions. 0.5 millimeter divisions. Millimeter divisions. The vernier scale has been constructed by dividing 49 divisions of main scale into 50 equal divisions. Find the least count of the instrument. Find the least count of the instrument. I will repeat it again. in a certain measuring instrument, the main scale consists of in a certain measuring instrument, the main scale consists of 0.5 millimeter divisions. 0.5 millimeter divisions. The vernier scale has been constructed. By dividing 49 divisions. Of the main scale into 50 equal divisions. Find the least count of the instrument. Find the least count of the instrument. 100, no? 0.01 millimeter. And then we can write this equal x times n minus n over n. Now x is equal to 0.5, no? 0.5. 0.5 because the main scale the gap between main scale, the value of the gap in the main scale is equal to 0.5. Then n minus simple n is equal to 1 puthe because 49 and 50 and simple n is equal to 50. Therefore, answer is equal to 1 over 100. 1 over 100 means 0.01 millimeter. 0.01 millimeter. And is that clear? Okay, Puti. Do you have any questions regarding today's lesson? Taggal again. Adrigak. Vadipura vela karana una. Taggal again. Do you have any questions regarding to this lesson? No. Yes or no? No. Okay, then write this question as a homework. A spectrometer. A spectrometer consists of a circular main scale circular main scale. Calibrated with 0.5 degree divisions. 0.5 degree divisions. Then the angle is 0.5 degree division. The vernier scale is constructed. The vernier scale is constructed. The vernier scale is constructed by dividing 14 divisions in the main scale. 14 divisions in the main scale.
What's that?
14 number of divisions. 14 number of divisions. 14 number of divisions in the main scale. By dividing 14 number of divisions in the main scale into 15 equal divisions. Into 15 equal divisions in the vernier scale. Into 15 equal divisions. 15 equal divisions. In the vernier scale. Find the list. Find the list. Find the list. That is the homework, okay? That's the homework, okay? Okay. I think you don't have any questions today. You don't have any questions today, no? So we can complete today's class with it. I will send the recording. I think, as we discussed earlier, Tuesday we will have an extra class from 7:30 p.m. to 10:30 p.m. Okay, please prepare for that. I will inform about that later. But definitely we will have that class with it. If there's a time change, then I will inform you. Okay. Meanwhile, if you cannot come to that class, please let me know. If you cannot participate for that extra class, please let me know. Otherwise, please try to participate. Okay, with it? Sorry. Sorry. Then we can complete today's class with it. Okay, everyone. Good night. Okay, I want.
Thank you, sir.
Welcome with it. Welcome with it. Welcome. Have a good time.